Dear colleagues, let me present you the results of our work on the topic of knowledge-based situation awareness process based on ontologies. This work was performed at Lviv Polytechnic National University. First of all, the growing complexity of modern world and inherent limitations of humans in making fast and correct decisions creates the need to offload the part of situation assessment and decision making to intelligent computer-based systems. This is quite a difficult task, and the major factors contributing this challenge is that we need to implement the process which includes the perception, recognition of patterns, and making decisions. We should also take in consideration the contextual nature of knowledge and mm, constantly adapt to changing context. And another limitation or constraint, the decision should be done in real time. There are several models formalizing the process of situational awareness assessment. We know such models such as John Boyd Observe or Ian Decide Act model of Ansley model, but the most popular and most used is the so-called GDL or fusion model, joint director of laboratories GDL. This model consists of five levels. In the level number 0, we record data from sensors, gather the data. In the first level, we establish correspondences between this data from sensors to entities and attributes of entities from knowledge base. In the next level, number 2, we do situation assessment, situation identification, analyze the situation, and the next level, we are planning actions according to detected situation, and also we assess the impact of those actions. And at the last level, we make performance assessment. The ontological approach to detecting implementing situational awareness is a very popular approach, and we follow it. And in current literature, it mostly uses one ontology or maybe two ontologies, like top ontology or domain level ontologies. And in our work, in our research, we argue that the use of big ontology would be very cumbersome, complex to handle, inflexible. And we propose to use a set of small ontologies, related small ontologies, such as contextual ontologies, situational ontologies, and task ontologies, in order to correctly specify the situations and actions, and also make decision in real time. So the purpose of our work is clarify the definition and establish dependencies of different small ontology of knowledge models such as contextual, situational, task ontologies, and contextual graphs. And in the process of acquiring situational awareness and specify how they relate one to another, how they fit into this process. The main premise of our research, it is we use the modified GDL models of situation awareness systems. We use also ontological approach in order to build conceptual models of situations, and we use several kinds of small ontologies types. So let's consider our approach according to different levels of GDL model. On the 0 level of the GDL model, we have an agent which has several goals, intents, which has its own states, and this agent observes the world using a set of sensors. In this setting, the context is a part of the world observed by the agents, and also in this context, we also include the goals or intents of the agent and its state. In the third level of GDL model, we read the data from sensors and we interpret this data as a value of attributes of concepts and relations. So at this level, we work with so-called contextual ontology. Contextual ontology describes the context, that is the world observed by agent, is a part of the world observed by agent. And based on this contextual ontology, we built on this level so-called conceptual model of current context, so-called a scene, which uses the relation concepts from contextual ontology. Interesting factor of this process is this conceptual ontology, and conceptual model is changing over time, and new elements come into context, and all the elements come out of this context, and the task of identification entities is simplified by reusing the entities identified in the previous time moments. On the second level of GDL model, we make an identification of situation. We name a situation differently from a context is a state of the world which presents some pragmatic interest to agent. Or maybe, if I can say it more precisely, it is a pattern in the state of the world which presents this pragmatic interest. The situation is stored as conceptual models, patterns of situation, a separate repository. There is dependency between contextual ontology and situational ontology. First of all, situational ontology presents only part of contextual ontology, or overlaps partly with contextual ontology, because it may, in most cases, it is smaller than contextual ontology, because it contains only relevant parts of from the context. And also, situational ontology can include elements which are not included in contextual ontology, in order to better understand the situation. For example, some historical elements, something which was before, or maybe some general knowledge which is not included in this context. An important problem which is resolved in this stage is identification of situational problems, patterns. There could be different approach to identification of such patterns. One of such approach is looking for cues, where Q is a combination of specific parameter values or range of values from the object of in contextual ontology, which can point to the probable situation. In the next level of GDL model, call it the impact assessment, we make decision about required actions. We specify those actions in more detail and assess the impact of those actions. Basically, this requires answering two questions. What change in the world is desirable given situation identified? How to introduce this change? In this stage, also we can use goal functions, which verifies whether specific states of the world, of the problem area, corresponds to the goal. In this stage, we can use contextual graphs in order to further detail actions and practices. If situation is given the situation is identified, we can have several different course of actions depending of specific parameters of this situation. So we can represent those courses of actions as contextual graphs having vertices of contextual knowledge and actions. And each actions in this contextual graph can be represented by yet another type of small ontology, so-called task ontology, and related to this task model. Task model describes how specific actions is done. Since same types of action can be reused in different situations, and this task models, task knowledge represent quite a different base of knowledge, body of knowledge, when we compare it with situational knowledge or, for example, contextual knowledge. And each task corresponds to the specific actions. It has also associated conditions of success or fail, and maybe conditions of performance, how well this task was executed, and so on. So there is a mapping between contextual ontology and task ontology, and also between situational ontology and task ontology, which allow us to feel the parameters needed to execute the specific actions. So in our work here presented, we show how different types of smaller ontologies can be used in a situation awareness process, their dependencies, and we believe this approach can result in the possibility of implementing situational awareness in real time, as a real time process. As a direction of further research, we foresee the research on the dynamically changing ontologies from one moment of time to another moment of time, and also formalizing the feedback mechanisms of how we can change, for example, our information gathering policies during the, depending on the decision made in previous steps or situation identified also. So do you have any questions?